It's happy to have you join me. So here is a 40-inch, is it? Oh, 39-inch Samsung panel, Samsung TV AUO panel. Sorry, Samsung TV AUO panel. Yeah, I just need to make that clear. This is probably one of the Series 4 or Series 5. Yeah. Okay, so ready to delve right into it. Let's see what the symptom is. Um, yeah, Spowron. Okay. Oh, so we'll have half screens. The backlight seems to be faulty. Some strips, maybe one or two strips are dead here. So that's why it's a little dark on this side, in this area. Uh, well, that's not what we're here to talk about. We'll be focusing on, in this live stream, we'll be focusing on the symptom. From here to here, that's the right side of the panel is black, like total black, as you can see. Okay, let me turn off this light so that you see more clearly. So, there. All right. Yeah, this is one of the like really durable Samsung TVs. Samsung AO panels durable too, although ELS, that is no side, no gate COFs, but still good, durable. All right, let's see what we have here. As you can see, it's AUO right here. There, AUO. Model is here. Let's zoom in for the. Okay, not very sharp now. I think I've zoomed in a little too. I've zoomed a little too far in, so you can't see that clearly. But I'll just say the number: 39T390HV and 031 3.1 XR. Yeah, we have some additional numbers. Yeah, but well, those are not well. Sometimes they are significant. It's important to consider them. 39T05-S01. Now let's talk about why this would happen. Okay, what are the likely root causes? Let's zoom out. Okay, what are the things that are usually responsible for this problem? Number one, okay, number one, we're going to start from the most likely root causes, the problem's faulty parts, rather, the most likely faulty parts. Uh, Most likely, it's the COFs. Yeah, I'd say the COFs. When I say the COF, I'm referring to this one, two, three. Yeah, they're usually the most common culprits, the most common parts that fail. But from them, you now go to components on the PCB. Here, components on the PCB, and then sometimes it's the traces on the PCB. Yeah, sometimes traces when you have corroded traces. Well, sometimes some traces just can I use the word, the expression burnout? Yeah, they just burn out. They just cut. So that's one factor as well. And then this also, this ribbon. Let me power off. This ribbon is also another common bad part. And then the last one is right here, the timing control board. So we're going to do something here. How do we know? How do we narrow down to the root cause? I mean, to the failed part. How do we like isolate, or like what sort of checklist? How do you take your checklist so that you rule out, all the root causes, all the failed, possible failed parts? Am I saying that right? I'm sure you get me. Well, first things first, what you do is to take voltage measurements here, right here. Let me zoom in just a bit. See here, this cup right here. This is where you should give the most attention to. Without going into details, I'll just say there are signals that are sometimes or that are mostly responsible for this. So if you check those signals, you can use a multimeter to check those signals, the RSDS. Check them. If you find any anomaly, any unusual readings, then you should give attention to that. You can do that quickly, or you could also do something. You could open up the bezel, reveal the cuffs, like this way. Check the cuffs. Yeah, check their state. Examine them carefully, because this happens. It's a common thing with AO cuffs, AO panel, the cuffs on AO panels. They burn out too, like pretty easily, especially if you don't connect this properly. Now, note that, guys, this is an important tip. If you don't connect this ribbon properly, if it shifts a little to the right or a little to the left, it can cause damages to the cuffs. You just see that they burn out. So I want to be careful with that. So, but in the case of this panel, I have checked. I have examined this already. I saw that they're fine. They're not burned. So I'll just lock this back up. All right. So we're good. I hope I didn't crack the screen. Let's see. Okay. Still okay. Still fine. Though only we need to check that now. All right. So let's go. Our lights. We need the lights back on. Okay. Now here's what I'll do. I'll have my multimeter set. So thanks guys for joining in. You can leave comments or questions. If you're not sure what I'm doing, especially if you didn't join the live stream right at the beginning, you can ask questions, leave questions, and I'll address them. Your questions will also ensure we have, or help us to have a lively class to some extent. All right. So here, power on now, and I'm going to take readings. I may not go into details what I'll be doing, but just watch me. I'll try to give some tips here and there. Okay, first I'm going to take readings of all this, and look out for any inconsistencies. Okay, checking. There's something I've just noticed here. Something I've just noticed. Let me check the rest now. Okay, so there's something is wrong. Something is actually wrong here. And if I were to move the panel here, if I take the readings here, let's see what I'll find. Hmm. Hmm. Okay, I think I'm getting the same vibe here. Hmm. Hmm. Okay. Well, yeah. There are test points that are reading abnormally high, and I wonder why that is. Okay, so what I'll do is, for me, because well, experience is on my side, so I know usually, apart from these signals that I just checked, I know that, okay, there are some other voltages that could result in this problem. So I'm going to check the test, take the readings on those likely voltages at each COF. Now, because like I've said this again and again, I hold myself back from revealing too much details, too many details rather. I'm just going to say that okay, I'll take certain readings now, and let's see what we find. Okay, so let's start here. Oh, where do we start? Okay, let's start here. Let me do this. Okay. I hope you know that there are clock signals too that are for the source COFs. It's important to ascertain the state of those signals as well, because without them, you could have, okay, you would not have this black screen. You would have a different symptom, actually. So I think I should bring this closer. I should bring it closer. Let me lower the tripod. Looks like I have a bit of cold here. Okay, let's bring it closer. So there's a technique I use. A technique that helps me to determine an abnormal reading or any abnormal reading. So, like in this case, I would give attention to signals where I noticed abnormal readings. Okay. So I'm noticing something here. There's a trace here that doesn't seem to hold a voltage that should be present. Okay. So here's what I'll do now. I want to try something. You know, in cases like this, what some people do is that they just replace this. They replace this to try to see if that would work, if that would correct the problem. But I'm not one to quickly replace these things. I would rather troubleshoot. I'll look for the fault on the PCB. Field components, you name it. So, but in this case, I want to try something. So with the TV raised up this way, I have my mirror, so I can monitor what's showing on the screen. I want to try to. I wanted to try something here. I hope I'm capturing everything that I should be having on the screen. Like, let's see. Okay. That's good. Okay. Okay. Let me see if I have this jumper wire that I use. So I'm going to try something with it and see if that will work. And I'll be using this to ensure that I do a good job, a safe job rather. Okay. Let's see. Any difference? No difference. Okay. No difference. Why is that? Okay, I think I need to check for a possible short. Let's see. Okay, checking it out. It's missing voltage here. I think I might need to look something here. Take the voltage from here to here. Let me do that first and then take readings afterwards. Oh, sorry, forgot. So I'll just take the voltage from a nearby source here. Let's see if after restoring this voltage, I need to do one or two other things. With my solder, yeah, I have it here. Okay. I forgot that there's something I thought I should do. On this PCB, I can see lots of what looks like corrosion. Yeah, it's a lot, but it's light and not deep. Yeah, maybe I should have cleaned up the PCB. Can I still do that now? Let me try to do that. I think it's a precautionary step I should take, just to make sure that there are no possible bridges. The corrosion is not causing some bridges, you know. Okay. So after what I'm doing now, I'm going to ensure that the voltages that come from the processor are all okay. That is, if it doesn't work. Okay. So I'm ready to look the wire. Oh, what's this? Funny. I'm almost done. Okay. Just this soldering and yeah, done. Done. Let's cut off excess wire. Okay, done. Now I can power on. That's what we get. Okay. That's fine now. But do we get, does that affect reading? Reading is too high. This is too high. This is too high. So what this might mean, what this might indicate is that perhaps there's a loss of this signal right from the processor. So let's see, let me check just here. Yeah, I think there's a loss of it. So now what I'll do is check for continuity to be sure. Let's see, I'll check the first pair. Okay, it's not even like it's not as, it's not close to 0 ohms, as close to 0 ohms as it should be. And that's not good. Let me use this one. I like this multimeter because of the light it has here. That light is one important feature. It's a very helpful feature actually. Okay, I might need to replace this probe. Yeah, I replaced the probes because I've altered these ones so that they're suitable for SMD measurements, SMD testing. All right, let's go now. Let's see. So guys, might want to look out for the light here. Too much. So when I take readings and you don't see any light, then there's a problem. I'm talking about this light, the green light. No light. That's not good. No light either. Wow. No light. Wow. Why is this? What happened here? Well, it looks like lots of signals are missing. Lots of this signal. Wow. Nothing. You don't say. Nothing? That is serious. Wow. Really? what happened here? Let's see. I I want to check to be sure that someone had not done something to this panel, or to the timing control board. I don't know. Like, did they use the wrong timing control board? Well, that's unlikely. That is unlikely because in the case of this side, the left side, let's see what we get. If I check, see. You see that, guys? Did you see that? Let me place it here. Sorry, trying to be sure it's safe. Let's check again. Wow, this thing is getting in the way of what I'm doing, the readings I'm trying to take. Okay, so you see, there's definitely a problem. The problem is from this end of the end, the time control end, the time control board end. We'll see, or if it's from here, well, we'll see that too. But what I need to check is I need to be sure we'll have the traces are connected right up to this socket, right up to the socket. So let me check for that now. Yeah, connected. Let me try this. Same, connected. Let's see this. Connected. Yeah. So this looks like oh good. Oh, I'm sorry. I didn't realize I had placed this a little too far away from the field of view. I'm so sorry, guys. Oh, okay. So far, I've determined that uh, the problem seems to be from this, either from this or from this the other end, the PCB end. So I'm going to take careful, like, do a careful examination of this and see what we'll find. First, I'll just replace this quickly and see what happens. I wouldn't like to use this. It doesn't look very clean. Like, you could actually swap this, put this here, put this there, and see if it works. But I just like to get a fresh one, like a really good one, one that I can quickly borrow. I think I have one right here. Yeah, so I'll just try this and let's see if it works. Mm, let me take a reading now. Oh, I need my lens. No, it's not this. So this is not the problem. Funny thing, what is now the problem? Let's check this end. Let me check carefully. Let's see. Let's see. Okay. I think I realized something. I think I was checking the wrong thing, the wrong traces. Oh yes, I was checking the wrong traces. Wow, what mistake I made. Oh yeah, I was checking the wrong traces. This hidden traces. Very funny. Oh yes, so what mistake? What big mistake. Aha, that's fine, huh? So we don't have broken traces. No, broken traces is not the problem. All right. So I'll just put you back. Aha. Now we're fine. I actually took voltage of the wrong trace, uh, not the corresponding trace to the one that has a problem where I noticed an abnormal behavior or something. So now let me check, like, do this over again. Hmm. I'm going to test the voltage on the signal point, the suspect signal point. Let's see what we find. Not you, not you. Okay, you. Okay. So I'll power off now, and I'll take the readings while it's powered off. 1, 2, 3. It's powered on now, and I'm checking, testing, and I'm not getting any voltage readings, but I should be getting. Should I? What should I be getting here? Hmm. Hold on a second. Okay. Power off and disconnect this side. You know, one important tip is when you have a problem here and the panel is divided into two equal halves, this side can help you troubleshoot what's wrong with the other side, you know? All right, so I need to be sure of these voltage readings. Okay, that's that. Okay. Oh, okay, so we get no voltage readings here, but we've got voltage readings there. So, guys, it looks like our processor is the problem, timing control board, and not quite, not just what I did here, although I did do some correction here. There was a missing voltage that I restored somewhere on the right side here. So, but now, as it is, I'll probably need to replace this timing control board, or if I can find, can I get a board, one that I can just test with? I'll see if I can, but that will take some time. And also replacing this might take some time also because I don't have anyone at the ready. You know, these ICs. So, guys, that's how far I've come. This is one reason why sometimes I like to check panels to some extent before the live stream. So in this case, I just did some minor checking because I always want to ensure that to a large extent we have a successful repair live. In this case, since we have need for parts here, it will take some time for me to really, prepare or search out the parts and all. What can I try something? Maybe just a moment. Let's see. I can get something out. Hmm. I think this is for an LG. So yeah, it's the same processor, so I think we can use it. But I'm not sure I want to take from this because this may still be good. I only need to fix the level shifter IC. Wow. Oh my God. 5:36. That's what time it is. Let me pause before I forget that it was on. Okay. Sorry guys, I'm still trying to see if I can do something about this timing control circuit. The processor. Okay. I think I have found something here. This should be the same. This should be the same. Okay, yeah, it's the same. Let us see if this works fine. Mm, mm, okay. So I'm going to power on now and test this one. Mm. Any comments? What are you working on? Yeah, it's a Samsung TV, half black screen. Okay, so I'm going to take readings of those very points. First, I need to check if this is working. Oh, this IC is bad. It's overheating. IC is bad. So how do we do this? Ah, man, this level shifter is dead. For that reason, I doubt that we can do any repairs on if I can use this. Although I could. Hold on a second. Oh, two ICs are dead here. These two are overheating. Oh, but I think what it means is I could actually borrow this and put it here. Well, I need to be sure that if I do that, if I did that, it will be fine. But wait, let's see. Why am I getting this reading? Hold on a second. It looks like there's something I'm missing here. Hmm. There's something I'm missing here. Wow, this is hot now. Really hot. Well, I wish I could just connect it and take readings of what I need to know. What I like. I'm really anxious to get this to work. I mean, seriously. Well, let's see if we have AVDD. If we have AVDD, then maybe I can get it to work. Okay, AVDD is fine. AVDD is fine, but hmm, is it safe to use this? Or might this actually be good? But I'm getting some things wrong. Well, sometimes while troubleshooting, we experience some mix up. Like you expect certain readings, but you didn't realize, oh no, it's different for this panel. I think that's probably what I'm getting with this. Hmm. Hmm. Hold on a second. Okay, I think there's something I missed. Something I should have checked. Let's see. I want to check the continuity of this again. Okay. Oh, sorry. Let me put this here. I think I may have checked the wrong trace. Oh, sorry. Disconnected. Funny me. Who would have thought that this panel would take this much time to troubleshoot? Oh, not good at all. Okay. Oh, funny me. Oh my God. What is wrong with me? Maybe because of the way I stand, the way I look at this panel. Like, yeah, you have to take things from a certain direction. Because if you're taking it from, you're taking, like, you're checking signals from this direction on this side, from the left to the right. You should do the same. It should go in the same direction, even though it's the other PCB. Yeah. No. I made mistakes here. Okay, so I'm going to take voltage readings again. This I'm now going to do proper. Aha, no, there's nothing wrong with this timing control board. It's not the board. Board is fine. So we're down to, we've ruled out the board. No, this is not the problem. It's not this ribbon. Now we're left with the COFs and the PCB. I noticed a problem on the PCB. I corrected that, but that didn't solve the problem. So what I'll do is I'll have to troubleshoot again, but that means we'll have to have a second part of this live stream. I will try not to fix this by myself. I mean, offline. I'll try to continue the live stream. Hopefully Friday. Yeah, because tomorrow I won't be here. Have to take care of personal important business. Yeah, so that's it. We ruled out timing control board, ribbon. We're now at COF and PCB. So let's hope that we would not have to replace any PCBs here. I checked before. I didn't see any damage on the PCBs, on the COFs rather. Let's hope we would not have to replace any COFs. But the PCB, I would endeavor to, to get to a head on it. Like, find out why, if there are other parts of the PCB that are faulty. Yeah, so that's what I'll do. But okay, let me do a quick check of this. Just a quick check of this trace before I go. This one here. Okay, this one is fine. This is fine. Okay, that's also fine. Let's see. Resistance on the pairs seem to be okay as well. Okay. So, okay. Okay. I think I've seen the problem, guys. Yep, found the problem. Yeah, I I never knew it would come this far. Like, seriously? Okay, so let's see where the problem lies exactly. Let's see. What's up, guy? Let me check again. I need to be sure. Sometimes we jump into conclusions, we draw the wrong conclusions much too soon. Let's see. Okay, let me check here. Wow, this live stream has dragged on for too long. Hold on a second. What am I getting here? Yeah, there. That's the problem. So without going into details, guys, I'll just have you know that, yeah, there's a breach on the PCB. Yeah, so that's the reason for this problem. But in order for me to isolate the area where the breach occurs, I'm going to do something. Okay, let me do this. Let's see. Let me do this. Let's do this. Oh, mistake. This is all I need to touch. Well, if you're still here, well, at least you're going to find out if what I'm doing, if the solution I have now will fix the problem. Okay, that's not the problem. So I'm checking the other COF now, just to see if that will fix it. Oh yeah. So that's where we have the problem. Oh no, that not there, not that. That's not where we have the problem. Okay, so let's keep going. Or oh yeah, actually I think I have to disconnect this too. What was I thinking? Okay, so let's check now. Oh yeah, so that's where we have the problem. Second cough. I'm hoping it's just the PCB and not the cough. I really do hope it's the PCB and not the cough. Well, but man, I'm not sure I want to continue with this. Guys, what do you think? This has taken too long. Like, seriously. It's, how long now? We started the live stream at about 4, 3, was it 3 something or 4 something? Local time. And now it's almost 6. Well, let's see. I think I would just like to get this sorted out up to a point where I'm like, okay, you guys can see that, okay, this is how to troubleshoot a problem like this. In the course of all this, I think, I mean, I've given out a little too much information though, but well, doesn't matter. I hope you received help somehow. You've gotten ideas on some of the things you could do when you have problems like this. Okay. Hmm. So what I'm doing now is to really ascertain that the second cough is the problem. But it's highly suspect now. When I say second cough, I mean the area, either the cough or the area where it's located. Oh no. Hmm. Oh, stretches are really tiny, uh, almost microscopic. Okay, almost done. Oh no, almost done. Almost done, guys. Just stay with me if you can. Why are you not sticking, guy? What's wrong with you? I'm playing some music here. I don't know if you guys can hear it. Coldplay, X and Y. No, not X and Y, not the track, but one of their songs. I think the first track on the album. I don't know if any of you is a fan of Coldplay. I'm a huge fan. Mhm. Wow. Okay. Why is this being tough? Mhm. Yeah, I think that's good now. Yeah, I think we're good. Just a moment, guys. I'm almost done with this. Uh-huh. So at this point, I'm going to power on and then take readings again. See what we find. See what we get. Wow. Same. Oh, so is this saying that the problem is from these two coughs? I hope not. Wow, that's not good. Okay, let me check. Wow, really? It's from the two coughs. No way. Problem is from these two COFs. Oh no. No. This is not good. So I actually should have taken the reading before I restored this connection here. Let me break it and check again. Take the reading. Okay. Take the readings again. Let's see what we get. Okay, come on now, guys. Oh, guy. What's up? No signals, no voltage detected. This is interesting. What am I doing? Wow. This is some tough screen to crack. So at this point, guys, I'm looking at the feasibility of continuing this, and I don't see it. So I'll probably end the live stream at this point and then continue, hopefully, next time. Not short here. Gee, not short. So, on the next live stream, if there'll be any on this screen, I'll probably just explain what I'll do if I do indeed do anything. What I'm getting at is it appears these two cuffs are faulty. The two cuffs seem to be faulty. I didn't notice any burn on them, so I didn't think they were bad, but it appears they might be bad. I need to take a careful look at them again. Let me do that now. Like, just a really careful look. I'll take a look on this side. I do not see any damage, any burn, any like this. This is really this is puzzling. Very puzzling. Let's use this one. Nothing. Okay, so what I'll do next would be just a video to highlight what I would have done if I would eventually do something on this. So guys, I'm really sorry for how this live stream turned out, but I would figure out if it's still the PCB that is the problem or the COFs. I'm going to ascertain that. But I am sure now that it's not the timing control circuit, it's not this ribbon, it is now more likely the COFs, bad COFs. And it's like this too, right here. So guys, thanks for joining in, and I hope you learned a thing or two, and we'll see what we will find next on the channel. Thanks again. My name is Akinyemi, or Akin for short. I'll catch you on the next one.